Okay, I'm quickly going to demonstrate the light sensor's readings using my phone flashlight on the first level, which is going to output about 12 lumens. We've calculated what the square area of the sensor to give us about 350 to 450 kilolux. So I'm turning on the flashlight now, shining it onto the sensor, and as you can see, the readings are about at 470. And then turning off the flashlight, removing the light source, you can see the light readings going straight down to 0 since we are in a dark room and there shouldn't be any light hitting the sensor. So now I'm going to be demonstrating both the total volatile organic compounds as well as the CO2 using the CCS 811 sensor. I'm going to be blowing right into the hole with a breath, and it should read about like 1500 to 1600 parts per million for CO2, as well as going up to about 300, 400 total volatile organic compounds just in a normal average human breath. I'm going to demonstrate that quickly. As you can see, the readings increase quite rapidly to about the average level of a human breath, and since it's an enclosed space, that reading is going to stay quite that high for a little while until there's some more airflow going through it. Perfect. We're just going to test the HT20 temperature and humidity sensor right now. We're at room temperature right now at 24 degrees, which we've verified through the lab's thermometer, and we're at about a very average humidity percentage for an indoor room at 30%. I'm just going to quickly put my finger right on the sensor to showcase the change in temperature and humidity. As you can see, the temperature is going up quite rapidly as well as the humidity, showcasing that the sensors are both working correctly and as expected.
So I'm going to be testing the time and alarm and the sound subsystem of this clock, and this is the phone app. And once I click the smart clock and sync the time, it shows the current time, which is 12:51, and then I can set the alarm time to be 12:52 a.m.
PM.
Like it says it uploads, but then it just won't like run the program after upload.
It just sits.
Yeah, it just sits. So
Okay.
At which point you
And
need to
then
reset.
once I set alarm is on. Oh, wait.
It is AM.
Okay, never mind.
Okay.
12:52 a.m.
But again, once you get it working.
Okay, I'm gonna set the alarm,
Just reprogram.
and the sound is playing now. And there's buttons on the sides here. If I press it, the alarm will turn off. And then if I press it again, alarm will start ringing. And I can press snooze to set the alarm off. And set the alarm to 9 minutes after the current time. And it says snoozed on the screen too. And that's it. I'll be testing the charging capabilities of our alarm clock, and just the USB cable coming out of the clock. And currently my phone is not charging, but once I plug it in, it starts charging, and then if I plug it out, it stops charging. That's it.
So I'll briefly run through the teardown of all the components within the alarm clock. In the middle, we have our ESP32, which is our microcontroller of choice. Right here, we have our power unit supplying 3.3 and 5 volts of power via a connection to wall power with this barrel jack connector right there. Right here, we have the USB charging unit to be able to charge your phone. And right here we have our speaker and amplifier setup to play the alarm sound. Right here we have the various gas sensor for CO2 and such. And then right here we have our light sensor. And down here we have our humidity and temperature sensor. And then last but not least is the display to show all the information.